Picture this: a lone lens cap tumbles through the vast emptiness of space, an inconsequential item, you might think. A mere piece of plastic, lost in the grand cosmic ballet. But here's the catch: appearances can be deceiving. In the vacuum of space, even something as small as a lens cap can become a dangerous projectile. It's traveling at thousands of miles per hour. It could severely damage a satellite, or even threaten the lives of astronauts aboard the International Space Station. This isn't science fiction, it's a stark reality. We've filled the space around our planet with debris, old satellites, spent rocket stages, even tiny flecks of paint, all of it zipping around at incredible speeds. And the problem is only getting worse. We've reached a critical juncture. We rely on space technology for communication, navigation, and monitoring our planet's health. But our continued access to space is threatened by the growing cloud of debris we've created. It's time to face this challenge head-on. The future of space exploration, and perhaps even our own safety here on Earth, depends on it. Our journey into space began with a roar. In 1957, Sputnik, a small shiny sphere, announced humanity's arrival into the cosmic arena. It was a moment of triumph, a testament to our ingenuity and ambition. But it was also the start of a new era, one marked not just by discovery, but also by consequence. Each successful launch, each satellite deployed, left its mark on the cosmos. We were leaving behind more than just footprints. We were scattering debris, the remnants of our celestial endeavors, rocket parts, defunct satellites, and fragments from collisions and explosions began to accumulate in Earth's orbit. For decades, this wasn't a major concern. Space is vast, after all. But as our presence in space grew, so did the problem. Today there are millions of pieces of space junk orbiting our planet. Some are large, like spent rocket stages, while others are minuscule, like flecks of paint. But size is deceptive in space. Even a tiny object hurtling at thousands of miles per hour can cause significant damage. Imagine a tiny fleck of paint, no bigger than a grain of sand. Now imagine it traveling at 17,500 miles per hour. That's the reality of space debris. Even these seemingly insignificant objects can pack a punch. Remember that lens cap? In the vacuum of space, it becomes a high-velocity projectile. The impact of even a small piece of space debris on a satellite can be catastrophic. It can puncture fuel tanks, damage solar panels, or disable critical systems. The result? Loss of communication, disrupted navigation, and billions of dollars in damage. And the danger isn't just limited to our technology. Astronauts working outside the International Space Station are vulnerable too. A small piece of debris could puncture their suits, leading to decompression and potentially fatal consequences. In 2016, a small piece of debris, likely a paint chip, struck a window of the International Space Station, creating a spiderweb crack. It was a stark reminder of the ever-present danger posed by even the smallest pieces of space junk. Section 4. The Kessler Syndrome, a domino effect in orbit. In 1978, Donald J. Kessler, a NASA scientist, proposed a chilling scenario. He theorized that as the density of objects in Earth's orbit increased, the probability of collisions between them would also increase. These collisions would create more debris, leading to even more collisions in a runaway chain reaction. This is the Kessler Syndrome. Imagine a cascade of collisions, each one creating a shower of shrapnel, each fragment a new projectile. This could create an impenetrable barrier of debris around Earth, making space exploration and even satellite launches impossible. It would be a self-inflicted wound, jeopardizing our access to space for generations. The Kessler Syndrome isn't just a theoretical possibility, it's a very real threat. In 2009, a defunct Russian satellite collided with a functioning US commercial satellite, creating thousands of pieces of debris. This event, along with other accidental and intentional satellite destructions, has increased the urgency to address the space debris problem. Section 5. Cleaning up our act technologies for space junk removal. Facing this mounting challenge, scientists and engineers around the world are developing innovative solutions to clean up our act in space. It's not an easy task, but the stakes are too high to ignore. One promising approach is the space harpoon. This device, still in the prototype phase, would fire a harpoon-like projectile to capture large pieces of debris. Once captured, the debris could be deorbited and safely burned up in Earth's atmosphere. Another concept involves using large nets to capture and remove debris. These nets could be deployed from a spacecraft and used to ensnare and deorbit multiple pieces of debris at once. Lasers are also being considered as a potential tool for space debris removal. By targeting debris with powerful lasers from Earth, we could potentially nudge smaller pieces into lower orbits where they would eventually burn up in the atmosphere. These are just a few of the many ideas being explored. It's a complex challenge, but the ingenuity that put us in space in the first place will hopefully help us clean up our mess. Section 6. A shared responsibility, what we can do. The responsibility for addressing the space debris problem doesn't fall solely on the shoulders of scientists and engineers. It's a shared responsibility, one that requires international cooperation and a collective commitment to responsible space exploration. Governments around the world need to work together to develop and enforce international regulations for space debris mitigation. This includes setting standards for spacecraft design, requiring end-of-life disposal plans, and promoting technologies for debris removal. Private companies, now playing an increasingly prominent role in space exploration, also have a critical role to play. They need to adopt sustainable practices, design spacecraft with debris mitigation in mind, and actively participate in international efforts to address the issue. But it's not just about governments and corporations. We can all do our part, educate yourself about the problem, support organizations working on solutions, and spread the word. The more people who understand the issue, the more likely we are to find solutions. Section 7. Our future in space. A call to action. The future of space exploration, and perhaps even our own future here on Earth, depends on our ability to address the challenge of space debris. It's a problem of our own making, but it's not insurmountable. We need to act now, before the problem spirals out of control. We need to embrace a new era of responsible space exploration, one that prioritizes sustainability and recognizes that our actions have consequences that extend far beyond our own planet. The cosmos beckons with untold wonders waiting to be explored, but to continue our journey among the stars, we must first clean up our cosmic backyard. Let's work together to ensure that future generations inherit a clean and sustainable space environment, one where the only things we leave behind are footprints, not debris.